Welcome to the Laird Thermal Systems Thermoelectric Cooler Product Training Module. This training will describe thermoelectric coolers, commonly referred to as Peltier coolers. The thermoelectric cooler product line will be examined by type with a discussion of the standard finishing options. We will end with a review of the Thermal Wizard specification and selection tool developed by Laird Thermal Systems. A thermoelectric cooler is a small device that creates a temperature differential across the module when DC power is applied. This phenomenon is known as the Peltier effect. A thermoelectric cooler is composed of two ceramic substrates and thermally insulating N and P-type semiconductor elements. Bismuth telluride is preferred as the semiconductor material because it offers very good temperature differential properties in a room temperature environment. Thermoelectric coolers are primarily used in cooling applications below ambient. Some examples of uses are to cool reagent tubs in clinical diagnostics, sample storage compartments in analytical instruments, and outdoor enclosures in telecommunication electronics. They can also be used for temperature stabilization applications in order to maintain peak performance of medical imaging, optical devices, or laser systems used in a broad range of telecom, medical, and industrial applications. Thermoelectric coolers have several advantages over alternative cooling technologies. They have no moving parts, so the solid-state construction results in high reliability and units can be mounted in any orientation. Thermoelectrics are able to heat and cool by simply reversing the polarity, which changes the direction of heat transfer. This allows temperature control to be very precise, where up to 0.01 degrees Celsius can be maintained under steady-state conditions. Their lightweight and compact form factor make them ideal for applications where size is limited. In addition, thermoelectrics have minimal electrical noise and are environmentally friendly because they use no CFCs. Laird Thermal Systems offers a diverse product portfolio of thermoelectric coolers with a range of cooling capacities in operating temperatures up to 150 degrees C. The low cooling capacity spectrum ranges from milliwatts to 10 watts, the medium spectrum from 10 to 100 watts, and the high spectrum from 100 to 300 plus watts. A design engineer should consider thermoelectric coolers when the system design criteria includes such factors as precise temperature control, high reliability, compact geometry constraints, low weight, and environmentally friendly requirements. Laird Thermal Systems series of thermoelectric coolers are designed to optimally perform with certain types of heat dissipation methods: conduction, air, or liquid cooled. This image indicates which series performs best in each of these heat dissipation methods. Thermoelectric coolers are ideal for applications that require active cooling below ambient temperature. Laird Thermal Systems provides the knowledge, innovation, and resources to ensure exceptional thermal performance for applications in the analytical instrumentation, consumer, industrial, and telecom markets. Laird Thermal Systems manufactures thermoelectric coolers to strict process control standards and pass-fail criteria in order to assure that its customers are receiving the best possible quality products. Thermoelectric coolers can heat and cool by simply reversing the polarity, which changes the direction of the heat transfer. This allows temperature control to be very precise, where up to 0.01 degrees C can be maintained under steady-state conditions. A standard single-stage thermoelectric cooler can achieve temperature differentials of up to 70 degrees C. Thermoelectric coolers can cool devices down to well below ambient. Colder temperatures can be achieved down to minus 100 degrees C by using a multi-stage thermoelectric cooler in a vacuum environment. Laird Thermal Systems series of thermoelectric coolers follow several part numbering schemes based on how long the product has been on the market. Each alphanumeric sequence indicates an electrical or physical attribute about the thermoelectric cooler, so an engineer can understand the difference in part descriptions. The thermoelectric cooler datasheet provides all product performance information. The top left chart compares the heat pumped from the cold side of the thermoelectric cooler, expressed as QC in watts. The heat requirement can be found on the left y-axis. Follow a curve to your required delta T. This will intersect with the current x-axis you need to apply to achieve the desired delta T. The top right chart shows the total heat needed to dissipate on your heatsink. Find the current along the bottom that you found from the first chart. Follow it up where it intersects with the delta T line. The total QH, or heat dissipated in watts, can be found on the left y-axis. The bottom left chart indicates the required voltage to achieve the specified delta T. Find the current you applied and follow it up to the delta T. The required voltage on the left will be where these lines intersect. The bottom right chart shows efficiency, or coefficient of performance on the y-axis, of the thermoelectric cooler based on current and delta T. Performance is based on a constant hot side temperature, TH, equaling 85 degrees C. For each thermoelectric cooler product family, Laird Thermal Systems offers standard finishing options for lapping, sealing, and soldering. Standard lapping tolerances of thermoelectric coolers are plus or minus 10 thousandths of an inch. This is sufficient for most applications where mounting of one thermoelectric cooler is used. Tighter lapping tolerances are required for mounting multiple thermoelectric coolers under one heat exchanger. For 2 modules wired in an array, Laird Thermal Systems recommends the lapping tolerance to be plus or minus 1/1000th of an inch, and for 3 or more modules, plus or minus 0.5 of an inch. This tolerance specification is recommended to maintain good thermal contact between the thermoelectric cooler and the heat exchanger. Laird Thermal Systems also offers metallization on the hot and cold side of the ceramic substrates in order to accommodate pre-tinning with indium tin or bismuth tin eutectic type solder. This is offered to accommodate applications requiring soldering of thermoelectric coolers onto the heat exchanger surface versus mechanical fastening. Most applications operate in a room temperature environment and cool to below the dew point. As a result, moisture in the environment will condense onto the cold side heat exchanger and may accumulate around the mounting hardware and eventually penetrate to the thermoelectric cooler. The presence of moisture will cause corrosion that will degrade the useful life of a module. Laird Thermal Systems offers 2 types of perimeter sealants to protect against condensation. Silicone, or RTV, is an all-purpose sealant that exhibits good sealing characteristics and retains its elastomeric properties over a wide temperature range, minus 60 degrees C to 200 degrees C. The sealant is non-corrosive and exhibits good electrical properties with low thermal conductivity. It is suitable for high-volume applications for ease of use and cost-effectiveness. However, over time, it is pervious to vapor migration, which can actually trap small amounts of moisture inside the thermoelectric cooler once the vapor condenses. This may or may not be a problem depending on life expectancy of the application and environmental condition. Epoxy is an effective barrier to moisture that exhibits a usable temperature range of minus 40 degrees C to 130 degrees C. When cured, the material is completely unicellular and therefore moisture absorption is negligible. Epoxy material exhibits a low dielectric constant, low coefficient of thermal expansion, and low shrinkage. Epoxies are ideal for applications requiring long life expectancies. However, applying epoxy onto thermoelectric coolers can be cumbersome as multiple fillers are required to be mixed and working life tends to be short, which makes it more difficult to automate for higher volume production runs. Laird Thermal Systems has developed the Thermal Wizard to help engineers simplify and speed up the process of specifying and selecting the right thermal solution. The web-based specification and selection tool assists engineers in quickly determining the optimum cooling solution based on their cooling requirement. In this example, moving the QC slider to the application's heat load of 5 watts and clicking Submit produces a quick selection table of the most optimum thermoelectric coolers for the application. If you do not know the cooling requirement, or QC, for your application, the Thermal Wizard provides 4 calculators to help you determine the QC requirement based on your application. In this example, we are determining the heat load for a sample cooler enclosure. There are 3 enclosure examples of different sizes to help you get started. Once you have determined the QC requirement, you can utilize the QC slider to specify the appropriate series of thermal management products and select the optimum solution. There are calculators for device cooling, enclosure cooling, air cooling, and liquid cooling, each with pre-programmed examples to help you quickly define the QC value and get your cooling solution underway. In summary, thermoelectric coolers are small devices used in cooling and temperature stabilization applications for medical, analytical, telecom, industrial, and consumer markets. Laird Thermal Systems offers a wide range of thermoelectric products that are designed for specific cooling capacities or temperature differentials. The Thermal Wizard tool is great for assisting engineers with cooling solution selection and simulation of operational parameters based on input attributes of the application. Standard finishing options are offered to accommodate lapping tolerances, sealing, and soldering to mating with the heat exchanger surface.